Hello, kiddos. We're going to talk about the basic air conditioning circuit. This circuit, the basic components of this circuit is good for window units, refrigerators, uh, the split system in your home, to commercial business air conditioners. They all have the minimum of these four basic components. These are the four things that you need to make an air conditioner. All right. Um, what I'm going to discuss today is what each one of these components do and how they correlate with one another. You're going to find out that, for instance, the evaporator is the opposite of the condenser, and the metering device is the opposite of the compressor. And hopefully this will help you learn and memorize the function and the flow of the circuit, okay? So we're going to start with the evaporator. The evaporator is like a net that you use for fishing. It catches heat. It absorbs heat. So it catches heat. So if the evaporator is the opposite of the condenser, so if we're catching heat here, we're ejecting heat here. So the evaporator absorbs heat, the condenser ejects heat. See how they're the opposite of each other. Matter of fact, you can take a line and make a little cross right here, because we can divide up the circuit right here. And I'll cover that a little bit more in a minute. All right. We're dividing the compressor in half. We're dividing the metering device in half. We're dividing the evaporator in half, and we're dividing the condenser in half. All right. So the reason why we're doing this is you're going to show, for instance, on a air conditioning system right here, between here and here, halfway through the metering device and halfway through the compressor, this becomes the high side of the system. And this becomes the low side of the system. This side of the line is low side. This side of this line is the high side. So it correlates with this. So this is the low side. So the opposite of this side is the high side. Okay? And how do we represent the high side and the low side? High side is usually red and the low side is usually blue, which, little common sense, you can figure that out, right? All right, again, the evaporator absorbs heat, the condenser ejects heat, okay? And then the metering device is the opposite of the compressor. For instance, the metering device reduces pressure to reduce the temperature, the temp. All right? So if the meter device reduces pressure to reduce the temperature, guess what the compressor is going to do? It's going to increase the pressure to increase the temp. So they're the opposite of one another. Simple enough, right? Okay. So why? We're conditioning. This whole process is either conditioning the refrigerant to absorb heat, or we're conditioning the refrigerant to eject heat. And the medium that we're using to absorb heat and eject heat, we're using refrigerant. So we have to change the condition of the refrigerant to be able to absorb it or to eject it. And it's got to be in a certain state. Because you remember, how does heat travel from a high to a low? For instance, if something is 800 degrees and something is 200 degrees, that 800 degrees wants to make the 200 degrees 800 degrees. So the 800 degrees is going to give up its heat to the 200 until they become equal. Once they become equal, there's no more movement. All right? So that's why we're reducing the pressure to reduce the temperature, so the evaporator will be a lower temperature than the inside house temperature, so it can absorb the heat. And then vice versa. The compressor increases the pressure to increase the temperature, so the temperature of the refrigerant is higher than the temperature in the outdoor arena, which is normally between 95 to 110 degrees, right? Which in Abilene, the normal range is 95 degrees. So we have to have the refrigerant higher than the outdoor temperature, which is, how does heat move? It goes from a high to a low. So as long as the refrigerant is above 110 or 95 degrees, then the heat from the refrigerant will give itself up to the outdoor temperature. The same way for the evaporator. As long as the evaporator temperature, the refrigerant in the evaporator, is lower than the temperature in the house, we can absorb heat. Because you remember how heat travels, it moves from a high to low. For instance, the indoor temperature is high and the evaporator is the low. In the condenser, the refrigerant is the high and the outdoor temperature is the low. So you remember how the heat travels from a high to a low. Okay? So, again, the evaporator absorbs heat, the condenser ejects heat. The metering device reduces pressure to reduce the temperature. The compressor increases the pressure to increase the temperature. Again, we're conditioning the refrigerant so we can either absorb heat or we're conditioning the refrigerant so we can eject heat. Hopefully that was a simple understanding of the basic air conditioning circuit. And I'm going to go over it one more time. How halfway through the metering device, it reduces the pressure and it reduces the temperature, which makes the evaporator usually around 40 degrees. Okay? And then it goes through here, absorbs heat, and it usually, the refrigerant heats up to about, at the most, maybe 60 degrees. Then it goes into the compressor. When it goes into the compressor compresses the gas and excites it, which increases the temperature. So it goes in at 60 degrees and it comes out 210 degrees. And even before it gets to the condenser, the temperature has already dropped to about 180 degrees. So it's already given its heat up before it even gets to the condenser. All right? So when it goes in there, the condenser, it starts to eject the heat. So once it starts to reduce the heat, the temperature reduces. So it gets down to maybe 100 degrees Fahrenheit, and it's now liquid. And here's where we come in with this other line. Everything on this side is the vapor side. Everything on this side is the liquid side. So this side of the line is the low side. This side of the line is the high side. This side of the line, halfway through the condenser and evaporator, this is the vapor. Halfway through this side is the liquid side. And here's the rule. You do not want liquid refrigerant going into the compressor. It has to be vapor going into the compressor, and it has to be vapor coming out. But halfway through the condenser, it starts to cool off and become liquid again. Once it's liquid, as it comes out of the condenser, it's liquid. We do not want vapor going into the metering device. You notice, see how they're different to one another? We don't want no liquid going into the compressor, and we don't want no vapor going into the metering device. These cause failures if that happens, okay? So we have to have nothing but liquid going into the metering device, and we have to have nothing but vapor going into the compressor. Liquid will damage the compressor. Vapor will damage the metering device. See how they're opposite one another. The evaporator absorbs heat, the condenser ejects heat. The metering device reduces pressure to reduce the temperature. The compressor increases the pressure to increase the temperature. This side of it is the vapor side. This half is the liquid side. This half is the low side, and this half is the high side. So halfway through the meter rise compressor, at the top is the low side. Halfway between them, the bottom half is the high side. Halfway between the evaporator and halfway between the condenser, to the right is the vapor side. To the left is the metering device. It goes from the liquid refrigerant goes into the meter device, sprays into the evaporator. As it absorbs heat, it becomes a vapor, comes out as a low pressure, low temperature vapor, goes into the compressor. The compressor compresses the gas and makes it a high pressure, high temperature gas. And then that high pressure, high temperature gas goes into the condenser and gets cools off the refrigerant and makes it into a liquid. It comes out a high pressure, high temperature liquid. The high pressure temperature liquid goes into the metering device. And then the metering device reduces the pressure of the liquid to reduce the temperature of the liquid to 40 degrees. That 40-degree liquid refrigerant gets sprayed into the evaporator. The evaporator, then the heat gets attached to the refrigerant, which changes the liquid refrigerant into a vapor, and then the low pressure, low temperature vapor comes out, and then the low pressure, low temperature vapor goes into the compressor, and then it comes out of the compressor as a high pressure, high temperature vapor, and then a high pressure, high temperature vapor goes into condenser, comes out as a high pressure, high temperature liquid. It then comes out, then goes into the meter device as a high pressure, high temperature liquid, comes out of the high pressure, comes out of the meter device as a low pressure, low temperature liquid. That's how it flows. That's the circuit. That's the continuous circuit that your air conditioner at your home in the house follows. That's the same way with the window unit. That's the same way your refrigerator works. Any type of heating and cooling device, this is the basic of how that circuit works. There's more components to it, but all those other extra components is to aid in this whole process, to help this process. All right? What I mean by that? The meter device is conditioning the refrigerant so we can absorb heat. The compressor is conditioning the refrigerant so we can eject the heat. All right? Okay, again, on this quadrant right here, the refrigerant coming out of the compressor, going into the condenser, is a high pressure, high temperature vapor. This quadrant right here, the refrigerant is coming out as a high pressure, high temperature liquid, and it's going in the meter device as a high pressure, high temperature liquid. In this quadrant, the meter device is reducing the pressure to reduce the temperature of the high pressure, high temperature liquid and changing it into a low pressure, low temperature liquid. And the low pressure, low temperature liquid is being sprayed into the evaporator. And as it's being sprayed into the evaporator, it's changing into a vapor, and it becomes, on this quadrant, it becomes a low pressure, low temperature vapor. And then it goes in the compressor as a low pressure, low temperature vapor. It gets changed into a high pressure, high temperature vapor. And then a high pressure temperature vapor goes in the condenser, gets cooled off, changes into liquid, comes out as a high pressure liquid, and high pressure, high temperature liquid, going into the meter device as a high pressure, high temperature liquid, coming out of the meter device as a low pressure, low temperature liquid, going into the evaporator as a low pressure, low temperature liquid, comes out a high pressure, high temperature, goes into the evaporator as a low pressure, low temperature liquid, comes out as a low pressure, low temperature vapor going into the compressor. The way to best explain how the liquid in the evaporator goes from a liquid to a vapor is, have you ever been to an amusement park and they had those fans and they spray a mist of water out of it, and it feels really cold even on a very hot day. That's basically what's happening inside the evaporator. It's being sprayed in there as a mist, and then as soon as the heat hits it, it turns into a vapor. All right? And this is just the basic circuit of an air conditioner or a refrigerator or a window unit. Anything is a cooling device at this point. This is how it basically works. Like I said, the other components aid in this process. I mean, there's components that help make sure there's nothing but vapor gets to the compressor. There's components to make sure that nothing but liquid gets to the metering device. And just remember these quadrants, okay? Remember, this is starting from the meter device. I like to start from the meter device. This quadrant right here is a low pressure, low temperature liquid. This quadrant is a low pressure, low temperature vapor. This quadrant is a high pressure, high temperature vapor. This quadrant is a high temperature, high pressure liquid. All right. On this line, going halfway through the compressor, dividing it in half, this line above is the low side, which we represent in blue. Everything from this line down is represented in high, is the high side. And we represent it as red. And you remember how heat travels from a high to low. So for instance, the indoor air heat is going to the evaporator. The high is the indoor temperature, and the low is the evaporator. Over here, the high is the refrigerant, and the low is the outdoor air. That is basically the air conditioning circuit in a nutshell. I mean, I could get more complicated, but this is about as simple as it can get. And it's not really too hard to understand if you pay attention. Just remember that the compressor is the opposite of the metering device. The evaporator is the opposite of the condenser. Halfway between it is the opposite of the high and low side. Halfway between the evaporator and condenser is the difference between the vapor side and the liquid side. And if you learn to draw this, put these, remember what they go and how they flow, all right? It's just how it flows. And it's continuous. As long as the air conditioning is running, this is how it continuously always goes. As long as it's balanced and properly charged, this should continuously go as long as you have the unit on. It'll work every single time that way, okay? Hopefully I don't want to get into more complications. I'm going to break down the condenser, the evaporator, and the compressor, and the metering device individually and talk about each one of those and how they actually function. But I wanted you to see it as a whole first, and then we're going to talk about how it ejects heat. The condenser ejects heat. We're going to talk about how the evaporator absorbs heat. We're going to talk about how the meter device reduces the pressure to reduce the temperature. We're going to talk about the compressor and how it increases the pressure to increase the temperature. All right? The same way with the indoor air. We're conditioning the indoor air. When the air goes into the air conditioner and then it comes out, we're going to talk about how we condition the air outside, inside the house, right? Hopefully, if you have any questions, you know my email, so just email me. Other than that, hopefully you enjoyed the video, and I hope I didn't go through it too fast.